Hello, my dear students. Welcome you all to Sri Jaindra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be dealing with organic chemistry. My dear students, as you all know that we have started haloalkanes and haloarenes. Today, we are going to start with the physical properties and the uses of some commercially important halogen derivatives. So let us start with the physical properties. So starting with the physical properties, in physical properties, we are going to discuss with boiling point. We will discuss about melting point. We will discuss about the dipole moment. Density and solubility. Boiling point, as you know, is directly proportional to molecular mass. So if we increase the size of the halogen atom as we go top to bottom, if we are having same alkyl group, then the order is Ri greater than Rbr greater than Rcl greater than Rf. And this is the increasing order of boiling point. As we all know that I is bigger, it is biggest among all these halogen atoms. So the bigger atom exerts more amount of van der Waals forces, and that is why the molecular mass increases, which in turn increase the boiling point. Okay. In case of isomeric halogen derivatives, the boiling point is inversely proportional to what we can say the boiling point is directly proportional to surface area and inversely proportional to branching. As the surface area increases, branching decreases, boiling point increases. Okay. Melting point, it directly depends upon the percentage packing efficiency, that is about the crystalline lattice. So more will be the branching, more will be the melting point, lesser will be the surface area. Dipole moment is defined as equal to mu q into d. As the distance of separation increases, charge increases, dipole moment increases. Density. Lower members of haloalkanes, especially bromo, ido, and polychloro derivatives, they are heavier than water. The density increases as we increase the number of carbon atoms per unit volume. Solubility, as we know, the halogen derivatives are slightly soluble in water. And as we increase the carbon length chain, the solubility decreases. Okay. Now we are going to discuss about the uses of some commercially important halogen compounds. Derivatives. Okay. Yeah. So when we discuss about the uses of some commercially important halogen derivatives, first we are going to discuss about chloroform. Chloroform, it is a colorless compound with pleasant smell. Colorless compound with pleasant smell. It is insoluble in water and soluble in organic solvent. It is insoluble in water. Insoluble in water because the tendency to form hydrogen bonding is less, and it is soluble in organic solvent. The vapors of chloroform are poisonous in nature. The third point is vapors of chloroform are poisonous in nature. Next, it causes temporary unconsciousness. So it is used as an anesthetic agent, but nowadays we don't use anesthetic agent. The boiling point of chloroform is 61 degrees Celsius. It is best solvent for fats, oils, and wax. For fats, oils, and wax. Iodoform is yellow crystalline solid. Having a melting point of 119 degrees Celsius. So these are the physical properties of what we can say chloroform. Now we are going to discuss about the uses of chloroform. It is used as an anesthetic. It is used as a solvent. Iodoform is used as a antiseptic. It is used in manufacturing of hypnotic drug called chlorocetone. It is used in the manufacturing of war gas, also known as chloropicrine. It is used in the manufacturing of triphenyl methane dyes, and it is used in the manufacturing of polymer called Teflon. So these are the prominent uses or the most frequent uses of these polyhalogen derivatives. These polyhalogen derivatives nowadays they are industrially very important when we talk especially the chloroform, iodoform. They are very important compounds. Okay, so there's a very important term that the biological importance of or the biological side effects of the chloroform is that breathing about 900 parts of chloroform per million parts of air for a short time can cause dizziness, fatigue, and headache. 900 parts per million parts of air when taken in causes fatigue, headache, dizziness. Okay. Chronic chloroform exposure may cause damage to the liver, damage to liver. When chloroform is metabolized to phosgene gas. So this chloroform it metabolized to phosgene. Okay. That is why the chloroform is stored in closed dark colored bottles. Okay. To prevent its oxidation. The next compound is dichloromethane or methylene chloride. It is used as a solvent, it is used as a paint remover and a propellant in aerosols. In aerosols and as a process solvent in the manufacturing of drugs. For making drugs, right? It is also used as a metal cleansing agent. Okay, metal cleansing agent. Methylene chloride harms the human central nervous system. Harmful for human central nervous system. Exposure to lower levels of methylene chloride in air can lead to slightly impairment of hearing and vision. Higher levels lead to impairment in hearing and vision. And higher levels lead to numbness in the fingers and toes, tingling sensation, nausea, dizziness. Okay. Direct contact leads to burning of cornea. When it basically acts as a skin irritant. So these are the uses, effects, side effects of dichloromethane or methylene chloride. Now we are going to talk about the carbon tetrachloride, CCl4. Carbon tetrachloride, it is used in the large quantities for the use in the manufacturing of refrigerants and propellants for aerosol canes. Okay. Secondly, it is also used in the synthesis of chlorofluorocarbons. Chlorofluorocarbons. Used in making of synthesis of chlorofluorocarbons and other pharmaceutical manufacturing companies. Okay. Until the year 1960, it was also widely used as a cleaning fluid, right? As a cleansing material. Also used as a degreasing agent. Spot remover. And fire extinguisher. Okay. Harmful effects includes liver damage or liver cancer, while the effects on the central nervous system are almost same as of dichloromethane and chloroform, can lead to permanent damage to nerve cells. In severe cases, these effects can lead to coma, unconsciousness, or death. Exposure to carbon tetrachloride can make the heartbeat irregularly or stop. Cardiac problems, cardiac arrhythmias. Okay. The chemical may irritate the eyes on contact, skin irritant. It depletes the ozone layer. Next is freons. One more important thing about freons is that they are readily used as in making of what we can say uh, the refrigerants. But nowadays we are using hydrofluorocarbons. They also have a negative effect on the atmospheric content of oxygen, but in comparison to what we can say, the freons, they are less polluting agents. When we talk about that carbon tetrachloride, it is the only organic solvent which is non-combustible, and that is why it is used as a fire extinguisher. Please remember the word pyrene. That is named as pyrene when it is used as a extinguisher, right? Now, freons. They are also polyhalogen derivatives. The nomenclature of freons, the common name of freon is freon CBA or freon C plus 1 F, where C is number of carbon atoms, B is number of hydrogen, plus 1, and A is total number of atoms of fluorine. For example, CFCl3, the name is C minus 1. So 1, what we can say, 1 minus 1, that becomes 0. So A is 0, B is H plus 1, no hydrogen plus 1, 0 plus 1 becomes 1, and C, total number of atoms of fluorine, 1. So we have 1, So 1 and 1, B and C. So if we write A, B, C, B, C, sorry, C, B, sorry, C, B, A, it will 1, 1, okay? So it is written as Freon 11, like this. This is the nomenclature, okay? Properties, freons are colorless, odorless, and unreactive. And unreactive and non-combustible liquids. They're having very low boiling points. They can be easily converted from gaseous state to liquid state. Therefore, they are used as a coolant in air conditioner and refrigerator. And refrigerator. It is used as an aerosol propellant in aeroplane and rockets. Propellant in aeroplane and rockets. It is also used as a solvent. Okay. So this is about the freons. Freons are usually produced by Schwarz reaction. By the year 1974, total freon production in the world was about 2 billion pounds annually. Most freon, even that then used in refrigeration, eventually makes its way into the atmosphere where it diffuses unchanged into the stratosphere. And that is why it initiates the radical chain reaction for the ozone layer depletion. Okay. Now the last is DDT. DDT. It is the first chlorinated organic insecticide. Paul Mueller, sorry, Paul Mueller of GZ Pharmaceuticals in Switzerland discovered the effectiveness of DDT as an insecticide. He was also awarded the Nobel Prize in Medicine and Physiology in the year 1948 for this discovery. The use of DDT increased after World War II. The scientific name is para-paradash dichloro diphenyl trichloroethane. Para. Paradash. This is the molecule of DDT. Okay. The use was banned in the year 1973 in US. Okay. It causes biomagnification as the amount of DDT it goes on increasing in the food chain as it is more soluble in the fatty tissues. So my dear student, this was the economical importance of all these polyhalogen compounds. Then we will be starting with the next chapter, alcohol phenol ethers in the next one. Till then, bye bye. Take care. Stay safe. Stay healthy.